recording. So we are here. And we already did this problem last time. We were just having so much fun that we just kept on going, and it was so cool. And now we're just going to keep cruising, okay? Ooh, there we go. So the main idea that we were picking up on, just as a recap, there's just a lot of formulas in this section. But the main idea is that every plane can be represented by a line or a vector, and that is that normal vector. So as long as we have a normal vector, we can describe what the plane should be like, blah, 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 right? Given that information, we can go and do all these problems. So it says, find the equation of a plane given this and that. And you know what? This is the very first one. I want you to do this. I want you to do this one. What? You remember exactly what happened last Thursday. It's been 6 days. You can do this. 5 days and 23 hours. Perfect. Yes. I mean, it's multiple choice. Dun, 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 dun. Dun, dun, dun. Or at least some possibilities. You don't have notes for that one? Uh-oh. It's okay. It was a snow day, so the snow ate your notes. And again, I just want to see if y'all can, like, point me in the right direction. Maybe at least tell me what I can't be. So I'm going to wait just like 20 more seconds. Just want to see what y'all come up with here. Good guesses. Five, four, three, two, one. What's the answer? Oh no. Oh no, no. That's way too much work. But that's good to see that. It's good to talk it over, right? It is. It is. So real quick, just to recap then, since apparently y'all didn't take notes, that's okay. So this plane is described by a normal vector, right? And that normal vector has, I'm just going to use x, y, and z, has an x, y, and z kind of like vector values, right? But rather, what they use here in this section is a, b, and c, because these guys here are those guys here. You see that? In a way, I had called this the slopes. It's the slopes of the plane. Just like a line has a slope, these are the slopes, and they're attached to your letters. Okay, so that's the A, B, and C part. So far, so good on that? Thusly, so I'm going to go back down now. Thusly, are you good with that? Okay, good. Thusly, if I go back down, these here are my slopes, right? And I'm looking for the slopes to be 3, -2, -1. 3, -2, -1. So far, that one looks pretty good. 3, -2, -1. So far, so good. What about the slopes here? I got a 1, 5, and a -5. Exactly. And then here we got a 3, a -2, and a -1. That one checks out. So my slopes are at least telling me kind of better, right? So far, so good. Well, in this case now we have a point. So what we have is a normal vector. I'm just going to do that. And then it originated at a point P naught. Now, let me show you an example of a different plane, a parallel plane. What if I had the same n vector down here, and then I had a different point that it was coming from? Let's call this P1. I mean, they look kind of the same, but I literally just moved it around on the paper, right? In a way, and this guy's like below, right? Not the same piece of paper, not the same plane. Parallel, but not the same, right? Not identical. So how can I know which one's which, right? How can I know it's not this one down here or this one down here or even one up here? How can I tell which one it is? And that's where we're going to use this point, right? Now, just to be like silly, the ultimate answer here is ax plus by plus cz is equal to some number that I don't know. And just give me a letter that would normally work here. Just give me a letter. D. Exactly right, D. D. So what I want to do is I want to plug in my numbers and I want to solve for D, right? Seems easy enough. So here we go. I'm going to start doing that. My A was a 3 and my X was a 0. My B was a -2. My Y was a 5. And my C was a -1. And my Z was a -5. And we just like solve. So we got 0. We got, yeah, exactly. So we got -5 right here. See, we got a -5 right there. Looking pretty good, right? Looking pretty good. So I'm wondering if there's like multiple correct answers now, because I think there's something else going on here though. Oh no, I see it. No, I don't see it. That's a tough one. Okay, so far so good. We got -5. I'm expecting a -5. So far that guy's got 2 check marks to me. But is there another way to do this quicker? Like, is this going to work right here? Do you see that? Is that good? We need a -5. Is that -5? No. But like, why am I not automatically disqualifying this guy? It's basically in a different form, and I'm putting that in its proper places in a way. I'm putting those 5s and -5s back up for a second. There's multiple ways. See, this is the one I was looking at, but what about this guy? There's my slope, there's my point. There's my slope, there's my point. There's my slope, there's my point. Make it equal to 0. Same thing, different form. You get what I'm feeling there? So then, and this is where I'm a little like, I'm just following the formulas here. This is where I'm a little bit, is this then correct? Well, if you notice, I got a 5. Oh, it's not correct. It's barely not correct. I got a 5 and a -5, right? And then what's this one associated with the x? 0. Exactly. So far the 0 makes sense. But notice that it's y plus 5. The formula always has a minus sign. That's how we use that formula there. Again, if you remember, and I know you do you remember this one right here? That formula? Exactly right. Exactly right. So the form is that, I need these minus signs to make it make sense. So it's got to be a minus in between here, essentially. I have a +5. It's not supposed to be a plus. It's supposed to be negative. It's like flipped. Yeah, of course. Sorry. Oh, good point. Yeah, if I plug in my original point in here, then I don't get 0. Yeah. And which I don't want to like cloud up and muddy all this stuff, but essentially this just doesn't work. And I want to I like this guy. He's cool. Verify, and yeah, there we go, that guy. Cool. So that was a lot of blah blah time, but now you're ready for the next problem. Any questions on that? Okay. Just kind of recognizing what works best. So I'm going to do the next one now. Are we good with the top there? Do you want me to scroll or keep it? No problem. I can sit here all notes because the snow ate them. Right. I was just so excited to keep talking. Good? Good. Okay. This is a you do again, and I'm gonna erase on the board a little. If you want to do that. If not, it's up to you. Um, so, same style, same ideas. Same styles, same thoughts. Like in a way, they're supposed to be super easy. Next time, I should also remember that I probably shouldn't go crazy at the last 5 minutes of class. Just get so excited about this stuff. I really like it. Like I missed y'all yesterday, man. No, I was very disappointed. I definitely wanted to be here. And that's how you know you got a job you like. You're like, snow day? Junk. I wanted to go in. So thinking about it, that's probably a job you like too much. You should probably cool it down. It's okay, Chad. Just cool it down. Okay, you're right. I gotta cool it down. Oh, I know she does. I appreciate her as well, but it's oh yeah. Let's do like 30 more seconds. No, I'm gonna call 15. Again, it's a direction thing. Gosh, how many times am I gonna say that? Okay. Which one is it? No letters? They're all very similar, right? My math lab's junky like that, ain't it? So what is my slope for x? The slope. Yes, it is. It's right here. The slope for that guy would be a -1. Exactly right. So then what would be the slope here for my y's? Perfect. And then finally for z? Perfect. So what I'm looking at for my vector, I guess, is -1, -4, and a +3. That's my a, b, and c. Those are my slopes. And so when I'm looking for an equation, it better have -1x minus 4y plus 3z equals blah. I don't really know yet. We'll get to that in a little bit. Another alternative method, which is perfectly fine, is we can use that point up there, which I might be giving this away a tiny bit, but might as well do it. Okay. I'm going to describe it here in just a second. Give me a second here. +2. Okay. There. Okay, so this one's totally fine, and that's the way they're going to want us to do this problem, right? Ultimately, they don't have all these parentheses, so we're going to have to do this eventually. Cool? Cool. So this is definitely the way we need to go for this problem for sure. But this is also legitimate. I have my same slopes, and then I have my point, but again, opposite signs. Notice I had a -2, now it's a +2. I had a positive, now it's a -1. I had a -2, now it's a +2. And that's how we get this. So this is a correct answer. This is a check mark for sure. That's good. But MyMathLab doesn't have that as an option. Make sense? Try to solve by plugging stuff in here and solve for a number, or should I just try to simplify this guy? Which one would you plug it in or simplify? Plug it in. Sure. Either way works, but yeah, let's plug it in. All about it. So then we got -1 times the -2, -4 times the 1, and then we got the 3 times the -2. And what do we get out of this guy? -8. Do we have a -8 up there? Oh, there you go. Oh, you like D? There you go. You got it. Boom. Very good. Oh, I didn't number 2 pencil it though. Hold on. Good though. That's good. That's good. Making sense? We're extracting the pieces from it, right? We're not have to do a lot. Okay. So the next ones are strict formulas. I already looked through this before class, so this one's just gonna be a formula. This is a formula. That's a formula. That's a formula. I don't know about that one. I mean, I remember it, but I just don't really remember right now. But let's go look at these formulas that we have. Okay, so it says distance formulas. Let's go look. So we got that guy. Okay, so here we go. Distance from a point to a line. Okay, so we got a formula. And then we got distance from a point to a plane. Cool? So we got point to a line, point to a plane. What's the difference between point to a line and point to a plane? Is there something like deeper ingrained difference wise? It's a thought. So we have a point and we have a line. Yeah. And so look, that's that distance between them. 90 degrees always to make it the shortest distance, right? So far, so good on that. Okay, here's another one. Point to a plane. I mean, it's already pretty close. We got a point. We got a plane. Now I want the shortest distance. 90 degrees. Yeah. My 90 degrees doesn't look good, but you get the point. You get the point. Ha ha ha, the point. Because it's a plane of. Okay, whatever. It's very similar, but what's going on here is, to me, this is just Chad language. This is definitely 3-dimensional. 100% 3-dimensional, right? While here, if I look at it at a different way, I know it's 3D for sure, but if I look at it in a certain from a certain view, I can make it 2-dimensional, if that makes sense, right? Or you could even think of this as a plane, and it's just that thin part that you can see. So it's almost the same, and that's why the formula should look pretty similar. We got a cross product with some of that stuff. Here we got a dot product, but it's all very similar. Okay. All right. So which one are we going to use for which application? I don't know. So it says we got a point and we got a line. And so let me just rewrite that formula. It was, I don't know. Yeah. PS cross V. Okay. And then I'm just going to write down exactly what they have. I'm going to make it a Chad version here in a second. Okay. There we go. What is PS? Is that like point to slope? A, B, C, D, F, G, H, I, J, K, L, M, N, P, Q, R, S, Q. No. I just passed it. Sorry. L, M, N, O, P, Q, R, S. Okay. I thought they were right next to each other. My bad. So, yeah, let's go and check out what PS means. There's a PS. There's a PS. What is this PS? Do they have a thing here? P. Nothing else. Oh, it just says right here. It's a point S, point P, a point S to a point P. So if I were given this here, it says point S to a line through point P. I'm going to call this one P, and I'm going to call this one S. But in the end, it doesn't really matter that much. Think if I, like, just conceptually for a second, what if I were to flip them? My cross product would be flipped in a way, right? But wouldn't it just be negative? We already did one of those, right? Versus the other. Yeah, exactly. So I just have a negative. But hold up, what's this top bar thingies look like? What are they doing? Need is to have 2 points essentially to make that little vector dude. This is my v vector, by the way, and then we're good to go. So let's figure out how to do that. Let's go down and try to figure this out together. Okay, so I have a point, so that's cool, and then I can make another point from this, couldn't I? And it doesn't have to be perfect. Go ahead. Yes. That's a lot of work. I want to do it as easy as possible, and hopefully this will work. You give me a t value. Give me a t value, an easy one. 0, I love it. So then the point at 0 would be, plug it in, 0, 0, 0. So we have a line, and I mean, it goes back and forth. I just picked a point. You know what I mean? I just picked a point. And that's at 0, 0, 0. Now, you might be thinking, well, the other point up here, it should be tying in at 90 degrees over here, so I need to actually get my point right next to it, right? Well, what's going on is that this formula takes care of that for you. What's happening is that you're getting like this distance there, and then you're like, only doing the projection of that. We kind of did a little bit of that work beforehand. Just let the formula do its work, if that makes sense. So then, if I have this, and this is, I like P and Q personally. If you don't like Q, I guess S is fine. Regardless, what would then be the vector between these two here? Like, what would I put for my vector between these 2 points? Yeah, exactly. 0, 0, -8. Or if you wanted to go the other way, it would be a +8, but it wouldn't matter, right? So you're saying from 0, 0, 0 to -8, you go -8. Easy enough. Cross. My v vector. I want to know the vector here for the line, right here. What would you think is the vector from the line? Uh-huh. Perfect. Yep. And then they're wanting to do the magnitude of that very same v vector here. Yep. So that's our formula, essentially. And it should take care of itself. It should not have to worry a whole lot. Now, I have to do this cross product by hand, don't I? Oh, man, so difficult, especially with all those zeros. Gosh. That's supposed to be a 2, by the way. Okay, there we go. You ready? So we got 0 times anything is 0. 0 times anything is 0. 0 times anything is 0. We got 0 times anything is 0. 0 times anything is 0. 0 times anything is 0. -8 times 2. Oh, okay. So we got -16. Let me get a little bit of stuff going on there. So -16. Remember what letter goes in this position? I believe it's just plain J. Yep. But you're right. J. And then we got -8 times -2. +16. But what's the letter that goes here? -I, very good. And then finally a 0 over here, always 0. And so my result, and I know I'm bleeding into the next problem here, is a -16, a -16, and a 0. So that's my cross product for the top. Cool so far? Okay. So what I need to do, and first off, I need to write smaller. But I'm going to do the magnitude of this vector divided by the magnitude of this vector. 16 squared, 16 squared, 0 squared if you want to do that. And then the bottom, 2 squared, 2 squared, 1 squared. All right. So without being too silly, I believe I got 16 square root 2 from the top. I'm gonna make sure that we're all on the same page with that, okay? I basically put a 2 in the front of that dude, and then I apply the square root to it. So I got square root 2, and I got the square root of 16 squared. They cancel. This is just a little math trick that you get over the years. You know, since I've been doing it for 17 years. Teaching, that is. I've been doing math for a lot longer, it seems. So yeah, you just pick up on these little tricks. It's a little different here because we have a 1, so I can't just like cheat that way out. But I got a 4 and a 4 and a 1, so I actually got the square root of it's 3. Square root of 9 is 3. Yep, you got it. Yeah, square root of 9 is 3. Very good. I like that answer. You can't reduce it down. This is the exact answer. Let's see if that's what they have. And boom, we actually got it. Right on. So I'm going to say trust the formula. Okay? Trust the formula. Because conceptually, I'd have to go and find a point that's closest, and then I find the distance from that using Pythagorean. All that takes forever. They've simplified it down using that projection formula from earlier by just saying, hey, just take the cross products of magnitudes and you're good. Cool? So it makes it a lot easier and more universal to find that. So this one's a similar. So any questions, by the way? Good? Getting the point? Yes? Head nods? Okay. Yeah, okay. Just making sure. Because, like, y'all can talk. I know. If you want me to mute the mic, I can do that anytime. No one can hear you on YouTube. They can't hear you normally, but I mean, you know. That's fine. That's fine. I got nothing else to do. I mean, we get out early anyways, so. So I want to do this next one. I almost want y'all to do the next one, but I want to make sure that we set it up properly conceptually, if that makes sense. I don't want to throw you in the deep end right now. So let me go back. We have another formula for the plane formula. See? So it's a little tiny different. N is my normal vector, my slopes, essentially. And what does it mean when we have... What would that represent? N over magnitude N, just that little guy. Unit. It's unit. So, okay, let's think about this for a second. We got a unit vector, and we're dot producting it, right? Because there are 2 vectors here, right, still. So, unit vector dot with the PS. Yes. Yep. Yeah. Yeah, exactly. Yep. It's just a movement of the same stuff. We did the projection formula already. I'm sure of it, right? Projection V, on U onto V kind of thing. And I'm trying to remember. It was U dot V. It was V dot V, and then it was times V, right? Oh, the magnitude. Right, magnitude of V squared. Yeah, the dot product actually makes it a magnitude unto itself, which is kind of silly. Yeah. So it's just a little thing. V dot V is the magnitude of V squared, basically. So this is similar to this. If you kind of like put those together right here, you know. But again, we don't need the vector because that's just a projection vector. We're wanting like the magnitude of this whole thing. That's why they just did this in a way. Kind of making a little bit of sense. I mean, it's not perfect. I'm not one-to-oneing it, but I'm saying it's that same style. Okay, cool. Because that might have been wrong. I don't really know. But moving on. So I want y'all to do it, but I want to set it up for you. Okay, so we got the distance is equal to, and again they got the silly PS thing, whatever you want to call it, dot, and then we got n over magnitude of n. I want y'all to try that out for a second. This one's, I think, personally, it's easier than the last one. Much faster, at least. Much faster. Because you know, we're being live streamed, bro. Well, not really. I'm just recording it. You doing okay, man? Okay, cool, man. Well, then I'll just let you study some Cal 3. I don't know if you know, but we're actually doing a MyMathLab pilot with it right now. Yeah, so we're not using WebAssign, we're using MyMathLab for this semester. It's different, but we were all promised that you can put in the unsimplified forms with the square roots and weirdness and just leave it alone. So far, I know, same here, man. But that's so far it's been working, right, guys? The crazy answers you can put in MyMathLab apparently now. So that's it's good because like yeah, that's the only way, bro. Is it Calc 3? That's the only way, bro. But like, did you want to actually talk to me? Okay, that's cool. Then I'll let you hang out, bro. Okay, awesome. Fun times. Y'all can go to the board still if you want to, if you're daring. I don't want to like desensitize, no, de-emphasize, de-incentivize. That's a big words. Oh, yeah. Let's do 20 more seconds again, just kind of seeing direction here. I'm doing the I do, we do, you do. Oh no, I do, you do, we do. Yeah, yeah, yeah. It's cool to kind of. Hmm? Well, it's on. It was online. Yeah, a little different. Yeah, I know, right? How's your Oh, they're doing whatever. How's linear for you so far? Good. Okay, good. Perfect. So the due date for linear is not this coming Monday, right? It's right. Okay, good. Yeah, so we got like a week and a half still, right? Okay, good. Because the first quiz is a doozy. Yeah. Have you looked at it yet? It's okay. That's good. That's good. Now to do the chapter 2 homework and then. Yeah, I know. I just skip it for now. There's some weird questions. There's another one. I know this is Cal 3. I know there's another one where the matrix doesn't want to expand and you need a bigger one, but it don't let you. You have to like click on it weird and then it opens up. I don't know. We'll get through it. Anyways, back to this. Here we go. So, what would you call my n vector? What would be the n vector? So then, yes. So then, therefore, the value of n would be perfect. Perfect. Okay. That PS business. Nah. I have to find another point in a way here, right? Well, if I did that, notice that I'd have 0, 0, 0 equals -1, which doesn't quite work, but it's a good thought. Is there a way for me to do something silly like that still? There you go. There you go. What if I had -1, 0, and 0? Wouldn't that give me -1 equals -1? So that's a true point on that plane. I don't know where the heck that is, but we got something. See how I'm kind of doing the cheater method a little bit? So that's cool. So then that's not my entire PS whatever vector they call it, but it's getting closer. So I've got this one, and I guess I subtract, because again, it's like terminal minus initial kind of stuff, my other point. So then, I guess, distribute the negative. -3, -3, +3. Are y'all okay with that? Okay. And again, you did not have to do it that way, but let me tell you, way easier to just let everything weird be 0. X is all by himself. That's the easy way to do it. My first thoughts, though, before Mason had said something, I was going to make Z somehow make that -1. If I had made 0, 0 blank, wouldn't I have had to use like a 1/2? Gross. You know what I mean? Totally fine. And then I just follow the formula here. So let's see what we get. So magnitude of, I got my -3, -3, 3. And then I've got my 1, -4, -2 over the magnitude of the 1, -4, -2. Just following the formula directly. Yes, of course. Oh, I did right here. I subtracted them. Terminal minus initial. Or you could do it the other way. I mean, it really doesn't matter because you're going to get this right here on the outside anyways. Good point. What would you rather do? Would you like to find a unit vector and get a whole lot of square roots? Or would you like to do a dot product first? Yeah, because you're going to get integers. So dot product, I get -3 times the 1. It's -3. -3 times the -4, 2 negatives, a +12. And then finally I got 3 times a -2. It's a -6. And I'm still saying divided by the magnitude of this dude. I'll just go ahead and put it 1 squared, 4 squared, 2 squared. I'm going to have a conceptual question here for you. Chew on it. Like you go and eat a steak, are you going to just try to wolf it down? Or do you want to like, yes. Or do you want to chew on it for a little bit and, you know what I mean, taste it? I just probably eat it fast anyways. These vertical bars on the outside of this, are they an absolute value? You see, technically there is a difference, technically, but it's all about dimensions. Are these absolute values? Yeah. And what about the previous formula? Yeah. Go ahead. It is going to be, and as we discussed far earlier, they are essentially the same, aren't they? Essentially. Yes. True, true. But what's funny is that that magnitude you want is already down here. Notice what's going on in the inside. This is just going to be a number, isn't it? Sure. How far? Yep. Yep. because if you go this way or you start over here and you go that way, I just want to know how far it was. That's very good. That's true. Yeah, this is technically an absolute value because we have a scalar on the inside. All of this here is a scalar. And so that's technically just plain absolute value sign back from second grade, right? But if you go back up here, both of these are magnitudes because what's the result of a cross product is a vector. And so a vector has to have a magnitude. Again, we know that it really is the same, but I just wanted to, it's dimensional. This one still has dimensions. This one here has lost it all. All the dimensions are gone. It's a single dimension now. I don't know. I think it's interesting. So I got -9 and the 12 makes a 3, and then divided by that. Thank you. And then we want it to be positive, so it's positive already. Yay! Now, let's see what my math lab says. And what? That is so different. It's not. It's. Let's check it. So, what if I pop it in the top and leave the number behind? Right? There you go. Is that what they had down there? Set. Yep. There it is. I know. Yes. Yes, indeed. I 100% agree. Yeah. Yes, I always stress leaving it as it is in that form. And like Eddie knows, I'm going to look over your exams. I'm going to try to add back points. When I see what you did, right? But if you just give me like 5, I'm just like, well, what happened? Of course, I go back through the notes, but I'm just, little bits like that always help. Good? Okay. Distance from a plane to a plane. Now, let's do a concept, and then, I mean, you already did that one. Oh, I can't have y'all do everyone. See you later. So a plane to a plane. So I got this plane here. Go ahead. Uh-huh. Good. You take a point, any point from a plane, right? Let's call it P. I like it. And then we're going to go down to the other one, right? The one thing, go ahead. In order, very good. Perfect. And you would have 0 as the distance, right? Very good analysis. It's got to be parallel. And if you look right here, then it surely looks parallel, right? So as an easy answer, I have a P, I have a Q, and I want to find the distance between them. And if you look right here, give me the easy answer. What is it? How much distance between them? 9. That's my answer, right? It's 9. And so I'm going to go over here, and it's not 9. So, but it's related to 9, isn't it? It's related to 9. And that the reason why is because we didn't follow the normal vector. So if you have another one and another one right here, you have to follow that normal vector in order to get it. But if you had it sideways like this, and we just took like what we did was a z value, basically a height kind of thing. This point here versus this point here, all the way down here. Can I scroll a little bit? Yeah, there you go. See how this point right here is on this plane, and you said this is the 9. But I needed to go the shortest distance, which would be this dude here. You'll kind of, okay, hold on. It just looks so junky. Let's start over. Maybe you saw it, maybe you didn't. I don't know. Let me try again. So I have a plane, right? And then I have, that's no, that's too horizontal. Too horizontal. I want it to be a little bit more slanted, right? And I'm saying, hey, find the distance between these two planes. And I would want to go straight across, right? That's the shortest distance. It's perpendicular right there and down there. But what we were doing was like, oh, well, this point vertically would eventually touch that point right there. So there's our 9 distance, right? Because we just literally took the vertical distance between them. That's not it. We want it following the normal vector. So how do we do it? And this actually goes back to the same formula. Isn't this technically going to be a point to a plane? Technically, because I just made up a point right here, and I have a plane. Same formula. So what we need to do then is construct our first point. Let's look at this guy right here for our first point. help me out. What numbers would be awesome to use as a point here? I love that. Look at how beautiful that made it, right? How easy. Find an easy way to do it. It's not always X, it's not always Y, it's not always Z. But what would be another alternative? Give me another one that's easy. Yep, 0, 9, 0. That's another point. Perfect. See how we're trying to keep it easy, right? Good. So any one of those would still make a 9 in the end. I'm going to go with the 1, 0, 0, of course, because that's really simple. Okay, awesome, awesome. I don't like using S, but since they're using it, I might as well. So we need another point over here. So what would be okay for this side? Yep, I love it. Yep, yep. Yeah, yeah. So yeah, both of those points will work. I'm of course going to choose the easy one for that. And so then my vector from both of these guys would be terminal minus initial. Terminal minus initial. What would I actually get for my vector? 1. Very good. I'm so tempted to put a 3. I'm so tempted at that 3. It's not a 3. It's a 1. Yep. Terminal minus initial. Yep, yep, yep. Very good. Yep. It doesn't matter. I mean, you could do that, and I'm happy because in the end, it's going to be absolute value. Yeah. As long as you change all of the signs, that's the important part when it comes to this stuff. So if you have like a 1, 2, 3, you got to make sure all the signs change if you're going to do that. Very good. So we got our one vector here, and then we have a normal vector, right? What would that normal vector be from both these planes? Perfect, perfect. And then I do my thing with these, right? So I need to do a dot product, and then I divide by the magnitude of n, and we're basically done. So I'm going to do this ps dot n. 1 times 9 is 9. 0 times anything is 0. 0 times anything is 0. Right? I now need the magnitude of n. So that'd be the square root of 9 squared, 1 squared, 7 squared. I haven't pulled out a calculator yet, and I'm not going to now. So, dang, bro. Like human calculator? 131? Because the answer. Oh, you're clever. Okay, I'm gonna verify with you, okay? I'm gonna go to Desmos for this. So, we had 81 plus 1 plus 49. Look at that. Oh, you're right. Look. Look, and you're just dividing those, and there's your answer. So yeah, not 9, but that other stuff. And that's okay. Takes it out of there. Yeah. So you would always have that vector distance to be the difference between D's right there. I'm not going to 100% it, but let's go. It's not a theorem. Let's go with a hypothesis. One level lower. Yeah. Better than a postulate. Methods are, yeah, Chad methods are, well, there's methods and there's Chad methods, so it's really far down. Yeah. But let's go with postulate, or no, hypothesis. I don't know. Do y'all know that stuff? We got theorem, hypothesis, postulate, and then method and Chad method. So yeah, because like we already knew the 9, so it's just we already know the numerator. We just got to find magnitude of n. We're done. Yep. No, I'm pretty much at the bottom. That's me. I'm at the bottom. Well, okay. Below Chad method is just wrong. So just the wrong one. That's funny. Okay. This one's a brand new formula, but let's look ahead right quick. So we got another thing that's cool, and then we move on. So let's just see if I can finish this one up with you guys. So angle between two planes. We got angle between two planes. It's very straightforward, right? And it looks the same as our original angle between two lines. So let me rewrite the formula. We got the arc cosine of n1 dot n2, and then the magnitude of n1 times the magnitude of n2, just like that. Okay, what would be my, what would be my n1? You help me. Very good. 0. There's no z's in there. There's no z's. Very good. All right. N2. What would I get now? Perfect. I like it. So with those, I could just rock and roll with this, and we're done. I mean, there's really not much else to talk about here on this problem. So dot producting them, I got a 100. 8 times 7 is 56. Right? No. Yeah. Okay. Good. Thank you. And then 0 times anything is 0. In the bottom, we have our square roots. So I got a 100 plus 64. And then in the bottom here, I got a 100 plus 49 plus 36. And I'm saying just toss that in a calculator. You can even see, we're talking decimals. That's a decimals thing. Let me do that on the side here. Nope, nope, nope. Let's do this and that and this. Cool, cool. So yeah, so the arc cosine of 156 divided by the square root of 164, and then times the square root of lazy. There we go. Let me expand this a tiny bit there. Okay, maybe a little bit more. There we go. Yeah. We got that for them. We got that. So I don't know. We're gonna find out here in just a second. Oh, it does. Oh, look at that. Yes. Yes. Oh, yes. Yep. And we will occasionally. You're right. Divide by the pi to get the number you want. Very, very good about that. I don't think that this one would get something because you could see my degrees are wonky. But I mean, if we were to, I'm just curious now. I mean, once in a while it might work on something weird like this. Yeah. So that's not a pretty fraction. So yeah. Okay. But that works. Right. It was radian mode. You divide by pi. In degree mode, you leave it alone. I guess, yeah. To know how much of an arc and all that stuff, yeah. Exactly. That was an easy one, right? We like easy ones. I'm not going to do the last one. I know I'm super excited for it, but we're not going to do it. But it's fun. So again, let me just recap on what we're going to do here. We're going to finish this one up tomorrow, and then we're going to go to this next section. It's all pictures, all multiple choice. I only have the 2 questions here because I'm planning on going to my math lab for it. So I'll just like pull up my math lab and go through the homeworks. We got like 50 problems on the homework. It's super fun though. Really cool concepts. And then all of a sudden, what? So like next week early, we're just going to go back and recap on things that y'all didn't like or had problems on. We can go back through the homework together. Yes. Sorry, I was just jumping on it, bro. Yeah, all good, all good. Let me like do that. Are we cool? Excellent, thank you. I'm gonna sign off. Are we good with this? Good to go, guys? Thank you.